So I have see two kind of data. One is weight gain, another one is calories consumed. So calories consumed. Please tell me, will you be able to control this calorie consumed directly? If we consume more calories, then our weight will increase more, isn't it?
Yeah.
So that's what we generally know. So calorie consumed, it is under direct control. So we can consider that as X. Now the weight gain. What is this weight gain?
Y.
This is a Y variable. Now I want to know the relationship that may exist between X and Y. So what will I do is generally step number one, go for a scatter plot first. Go for a scatter plot. Then you can either go for correlation. And then you can go for regression. Sometimes step 2 may not be required. You can directly go. So we'll see how we can do it. So first you go to graph, go to scatter plot, and simple scatter plot. You have Y variable is weight gain. You double click. X variable is calorie consumed. That also you double click. Now you give OK. So the scatter plot is developed. In scatter plot, the X variable is called predictor variable. The Y variable is called the response variable. We are interested in optimizing the response variable by optimizing the predictor variable. That is, by optimizing the X, we wanted to optimize the Y, right? And now looking at the scatter diagram, please tell me what kind of relationship that is found to exist. Well, there are certain things we could observe, by looking at the graph. As the X is gradually increasing, you can see, isn't it? The calorie consumption is gradually increased along X-axis. What happens to the weight gain? Weight gain is also
increasing.
Going up. This is called positive relationship. As the X increases, Y also increases. So whether the relationship is positive or negative, how do you understand? Initially from the scatter diagram. The scatter diagram gives a clue. The relationship is positive, right? Let me type that also. Right? So what we understood right now is the relationship is positive. Moreover, look at the scatter again. Now, are you able to notice the way the Y is moving? It is somewhat, along a linear path. Can I say like that? It is going along a straight line, isn't it? Approximately. Yes. Though the points are slightly going up and down, yes, you can't get them on perfect linear manner, but it can go up and down. So it is somewhat linear, isn't it?
Yes.
So the relationship is not only positive, the relationship is linear. The moment you understand the relationship is linear, you can measure the strength of linearity. But now looking at the graph, approximately we can judge on the strength also. If I imagine a line here, in order to imagine a line, let me go for another scatter plot. Scatter plot with the line. Scatter plot with the line. That line is called regression line. Scatter plot with the line. And now the Y variable is once again weight gain. X variable is calorie consumed. I give OK. And now you can see the line also. You can see the line also, and you can see the point also. Do you observe the points are very close to the line?
Yes.
In that case, you can say the relationship is not only positive, not only linear, also strong. Relationship is positive, relationship is linear, but also it is strong. But those of you who have a problem in concluding all the three, right? Like you are not able to understand whether the relationship is positive or negative. You are not able to understand whether the relationship is linear or curvilinear. You are not able to understand whether the relationship is strong or moderate or weak. Then definitely you can make the right judgment using correlation analysis, because scatter analysis is a visual analysis. You have to interpret only using the scatter diagram, but correlation analysis is based on a numerical value. right? The numerical value is called Pearson correlation coefficient. What is that called?
Pearson relation coefficient.
Pearson correlation
Coefficient.
coefficient. And this generally denoted by the symbol small r, right? There is a formula and you can learn the formula, or you don't have to learn the formula. But the r is actually a function of the, x bar. X bar means the average of the x values. Y bar, the average of the y values. Sx, the standard deviation of the x values. Sy, standard deviation of the y values, and the number of samples you have taken. Using all these things, you can actually find out Pearson correlation coefficient. So we'll now go for Pearson correlation coefficient. So go to stat, go to basic statistics, go to correlation. When you go to correlation, you can select both variable and then bring it here. And now you just say okay. And now what we understand here is Pearson correlation of weight gain and calorie consumption is 0.97. So what we got is R equal to 0.97. And now tell me, this value 0.97, is it a positive value or negative value?
Positive value.
So the relationship is positive. Whatever conclusion you have drawn already using the scatter diagram, right? And the same conclusion you are able to draw. And now the R value generally lies between -1 and +1. The center value will be 0. When it is -1, it
Negative.
means relationship is on the negative. I
Negative.
would have said negative here. I have said positive because it is on the positive side. And if it is close to 0, it means no relationship. It means no relationship, close to 0. But close to 1, strong linear relationship. Strong linear means, and when it becomes 1, we'll call it perfect. Perfect linearity, right? So 1 and -1 means perfect linearity. 0 means no linearity. 0 means no linearity. And in between values, moderate. Generally, we say correlation like 0 to 0.4. We consider the correlation as weak. And 0.4 to 0.7, we consider the relationship or the correlation as moderate. However, from 0.7 to 1, we consider it as strong. This is the guideline. So positive side as well as negative side. Positive side means strong positive, negative side means strong negative.
So here only one thing. Here you're telling correct, -1 also, and 1 also will be linear. So that I'm not getting.
Linear means, it is straight line. Positive means the line will be going upward. Negative means the line will be coming downward.
But it's not okay.
Yes. Instead of line going upward, the line will be sloping downward. When the line is sloping downwards, you will get negative values, right? We'll see one such case also, no worries. So now we got this thing, right? Now coming to 0.97. So 0.97 is positive, not only positive, it is now strong positive. Can I say like this?
Yeah.
It is not only positive, it is strong positive. And I can also say it is strong positive and of course linear, you can say, because it is perfect linear, strong positive linear relationship. Why do I want to know whether it is linear or not? If the relationship is linear, then the equation of the red color line can be determined using this formula, can be derived using this formula. What is this formula? Y equal to mx plus. Hope all of you have studied this in your lower classes, right? Somewhere in the school or college you could have studied. So y equal to mx plus c is always the equation representing a straight line. Equation of the straight line is y equal to mx plus c. Do anybody here know what is m and c? What is m here?
Mean value.
I'll tell you. So m is the slope of the line. M is the slope of the line and c is the y-intercept. We'll see all of them. What is that, right? And C is the y-intercept. And so we understood all these things. And now R equal to 0.97, right? I want you to find out R square. I want you to find out R square. What is R square? 0.97
into 0.9.
into 0.97. Can one of you tell me how much is the value now you are getting? Is it correct? 0.9409.
correct.
Is it coming, right?
Yes.
It means 94.09%. Here you said, we said, the relationship is strong. So how much strong it is? That means,
94%.
it can influence your wife to the extent of 94%. It means the influencing power is 94%. So what is the influencing power your wife has got on your decision?
94%.
94%.
More than 90%.
So 6% of the time you are on your own. You take your own decision. But 94% of the time, your wife is influencing your decision. Same way. 94% of the time, Y changes because of the changes made in the X. But occasionally, 6% of the time, Y can change due to other factors also. If the influence X factor has got on Y is 94%, can you not understand that it is the single root cause for the problem? Am I correct?
Yeah.
Because 94% of the changes you have observed in the Y variable has come from the changes you have made in the X variable. That means if you control the X, 94% of the problem or deviations you have observed in the Y variable will get reduced. Only there will be a minor deviation, isn't it? That minor deviation is tolerable. So do you now understand how are we actually addressing the problem? Addressing the problem is fixing the root cause. And root cause is already confirmed. What is the root cause? X variable is the root cause. What is the influence of the X variable? Now R square is answering the question. Am I correct? So R square is called coefficient of determination. This R square is called coefficient of determination. In case your R square is very low, let's say R square is only 30%. What does it mean?
Means Y to be rectified.
Why?
Y to be rectified.
No. If R square is not 90% or 80%, it is only 30%. It means R square depends not only on the X, but also on some other factors. The factor what you have, trying to optimize is one of the factor, maybe X1. There could be X2, there could be X3. That means root causes are multiple. Your decisions are influenced not only by your wife, but also by your mom. Your position is now very critical, isn't it? You have to adjust to both, isn't it? Something like that. Your wife also should listen to X1, should also listen to X2. So if you want Y to move in your favor, you must adjust both X1 as well as X2, isn't it? If you are taking decisions based on your wife as well as your mother's opinion, then if I want your decision to be in my favor, then preferably I should talk to both of them. I should tell your wife, to put a strict order, similarly your mom also. So what will happen? Now you will come in line. Similarly, when the Y depends on more than one factor, you can understand that will appear in R square. The lower R square means the factor not sufficient. You have considered a factor and which is not the
real cause.
Which is not the not real cause, not the only cause. There are multiple causes. It is one of the cause. It is one of the cause. Still, you can consider that as one of the root cause because the impact is considerable, 30%. Another factor has got 40%. Another factor has got 20%. So now I have to work with the three factors to make a significant improvement in my Y variable. So you can think of using the correlation when you are studying only one factor. One factor is X, the other factor is Y, your response, right? When the number of predictor is just one factor, then go for the correlation. If the number of X factors are more than one, then you can directly go for regression. Is it clear to all of you so far?
Yes, sir.
Yes.
Any questions to me? You all know how to conduct the scatter analysis as well as correlation analysis. And now the important condition is your X, comma Y. Both should be continuous data. Then only all these formulas can be used. You all know continuous data, right? X also should be continuous, Y also should be continuous. Any questions? Anybody? All of you are comfortable with scatter analysis and correlation analysis? Yes.
Yes, sir.
All right. So now let us go for the regression. So what is regression? We have to frame the mathematical equation, or we have to we have to generate the equation of the red color line, this red color line. The equation of the red color line should be obtained. So we'll do that. So go to stat, go to regression. Just a second. Go to stat, go to regression, and you can go to regression, fit regression model. Fit regression model. What is your response variable? Weight gain. Select that. What is your predictor variable? Calorie consumed.
Calories.
So you select that also. So these two things are taken. Now model. Model, there is only one term. One term means only X will be there. If there are two factors, let's say X1, X2, then there will be X1, then there will be X2, then there is a chance for X1, X2 also to come. X1 into X2, right? So that complication is not here. So you can just click 1, and then you give OK. And now you again give OK. Now the regression equation is generated. All of you are able to see the regression equation here.
Yes, sir.
Weight gain equal to minus 754.6 plus 0.4631 into calories consumed. And now here you can compare this equation against y equal to what is the equation format we said? This is the equation.
Y equal to mx plus c.
Mx plus c, where m is the slope of the line. M is the slope of the line. C is the y intercept. Now, what does it mean? The m will help you. M is also known as regression coefficient. M is also known as regression coefficient. And now look at the m value. When the m value or regression coefficient is positive, right? M is positive. That means the relationship is positive. That means when I increase the X, Y will increase. That we have understood in correlation itself. Regression also conveys the same information. And also, m equal to 0.4631 is telling me that if I increase X by 1 unit, my Y will increase by 0.4631 unit. You understand? What is it telling me? When I increase X by 1 unit, then Y will increase by 0.463 unit. What is your Y? Weight gain. Y is your weight gain. Suppose if your goal is reduce 5 kg. That's your health goal. Now tell me, what will you do? What will you do?
5 into 0.43.
Will you, wait, will you reduce, let's say, okay, maybe in grams. Let's say I want to reduce 500 grams weight. And now, will you increase the X or decrease the X now?
Decrease X.
Very good. Now I will decrease the X. And just to get 0.4631 grams down in my weight, how many calories I should consume?
0.2.
No. 1 calorie. 1 calorie when I reduce my calorie consumption by 1 unit, my weight gain will come down by 0.4631 unit.
No, here 1 unit means it's 1 kg or 1 gram.
See, consume calories, food consumption we measure in calories.
So that we are giving 1 as same. Okay.
Yeah, and weight gain is measured
Grams.
in terms of grams. So 1 calorie can impact 0.46 gram, approximately 0.5 gram.
Okay.
Right? So you want to reduce 500 gram. Now tell me how many calories you should consume. Approximately, isn't it 1,000 calories? Isn't
Yeah,
it?
1,000. Yes.
Yeah, because the relationship is telling like that. So this is how you can interpret. Now, what kind of decision you have to take? What kind of optimization you need to do to arrive on the required Y value, which is guiding you? The regression is guiding you. Now, when you call all this team member for a discussion, having defined the problem, having measured the problem, having analyzed the problem. Analyze means root cause is confirmed and root cause is validated and root cause sufficiency also studied. I mean the influence also studied. Now you understood that the factor is single root cause, solo root cause. Sometimes multiple root cause will be there. If you have done all these things, tell me, will you be able to talk about the solutions correctly? Yes.
Yeah.
You can talk about the solution, isn't it?
Yeah. Yes.
And that's how the solution is getting evolved. All your brainstorming discussions can go on in a healthy manner if you have all the information readily available. Now let us look at the graph again to understand little more things. Now this is the graph, and now in this graph, brush. Oh, what is the brush? Okay. Now in this graph, I want to measure the slope. So what I want is, I want you to draw a horizontal line that is drawn. I also want you to draw a vertical line. I think all of you will be able to draw the line, isn't it? A horizontal line and a vertical line. After drawing a horizontal line, is it possible for you to measure the length of the horizontal line?
Yes.
Similarly, can you measure the length of the vertical line?
Yes.
Yes. Measure these things and let us go to the worksheet. Now let me say, the measured value of X is called delta X. Sorry, I should not write here. So delta X. Yes. Okay. Let us say X only. The X value is measured and the Y value is measured. Now what I want you to find out is, find out Y by X. That Y by X will give you a value of 0.4631. Do you all understand how the 0.4631 came? You originally had the scatter diagram. You originally had the red color line. And from the red color line, the 0.4631 is derived. How it is derived? At any point on the line, you draw a horizontal. That is nothing but your X value. And then close it by a vertical line. So now vertical line length is Y and the horizontal line length is X, and Y by X will be 0.4631. Why are we doing this? We can generate the equation ourselves. Do you all understand? The equation was generated by MINITAB. It is generated like this: y equal to 0.4631 minus 754.6. This was the equation. Am I right?
Yes.
So now 0.4631, how it came, I have explained. Now you can do it yourself. For any problem, if you have the regression line, then immediately the M can be derived, number one. And now I want to know the C also. So if you want to know the C, again, what you need to do is you have to extend the line. The line is here. Just extend it. When you extend the line, can you see the line is crossing the y-axis at a point? Am I
Yes.
correct?
Yes.
Yeah.
The line is crossing the y-axis at a point below the zero level. Below the zero level. Find out the point. That is found to be minus 754.6. That is found to be minus 754.6. And now what is that minus 754.6? That's here in the equation. Am I right?
Always.
So this minus 754.6 is nothing but y-intercept. Is nothing but y-intercept. The y-intercept is understood, and the m value also understood. That means you can write the regression equation yourself. Is it clear? Each and every piece of the regression is discussed. Am I correct?
Yes.
Now, see here. I have this regression equation. Sorry, I have the regression equation using this data. This is experimental data. Suppose my X is, let's say 1850 grams. What could be my Y? This is my question now. Right, this is my question now. So let us see how we can do it. This is called, prediction. This is called prediction. This is called prediction. So how to do the prediction? Go to the same stat. Go to the regression. Go to the regression. Stat regression. Come to the regression. Okay. Come to the regression. Fit regression model. We have fitted it already. Fitted it. Okay, let us do it again. Right. Everything is there. Let us do it again. It is done. Now again, go to stat. Go to regression. Again, regression. Now predict is enabled. Now go to predict. Now what do you want to predict? I want to predict weight gain. And for what value of weight gain? Calorie consumption 1850. So I type 1850 and now it will throw away weight gain. You understand how much will be the weight gain you can expect? When I maintain a calorie level of 1850 from my current level, I will increase a weight by 100 gram. Clear? All of you understand?
Yes.
Now, there is a standard error of fit. Standard error of fit. This we must understand. This we must understand. And once you understand that, you can understand 95% confidence interval. You can also understand 95% prediction interval. Right? What is this CI? CI is confidence interval. PI is prediction interval. Now look here. Look at the prediction interval. Whenever someone, whenever the calorie consumption is 1850, you can expect the weight gain to be between these values. What is this value? 107 gram and 311 gram. You understand? Whenever the individual have a calorie consumption of 1850 grams, his weight is supposed to increase anywhere between 107 gram, minus 107 gram to 311 gram. He can reduce weight also. He can increase weight also. Do you understand? The based on the variation in the data, it is also telling you that there is also a chance to reduce the weight. There is also a chance to increase the weight. But in our case, it came like, when I substitute, it is 1 or 2. But when I do the exercise again, when I ask the person to maintain, the calorie consumption for 1,850 calories for 1 more week, prediction is telling me the weight can also go down. That means, your equation, is not too good in terms of prediction. The prediction interval is very wider. Prediction interval is very wider. And look at the confidence interval. The confidence interval, is shorter. Confidence interval is shorter than prediction interval. It is saying that it will vary from 37 to 166. Now, what do we understand? The prediction interval is found to be greater than confidence interval. Hope all of you can understand this, right? Prediction interval is more than the confidence interval, because always prediction is for single value, right? And the confidence is for average value. I do not know how many of you understand that. Single value means I just do one experiment. On the X, and then I will note down the value of Y. When I do only one experiment, then that single value is expected to fall in prediction interval. How many of you understand my statement? I did an experiment once, and that single Y value is expected to be inside the prediction interval. Another person is doing the experimentation in this manner. He is conducting the experiment 3 times. How many times? 3 times. Now he will have 3 Y values. When you have the experiment repeated 3 times or 3 experimental values, you take the average. Now the average will be within your confidence interval. Do you understand what does this confidence interval is speaking, and what is this prediction interval is speaking? Prediction interval can get you the single experimental observation value. The single experimental observation value is expected to fall inside the prediction interval. However, the average of the multiple experiments is expected to fall inside the confidence interval. So which is narrower? Prediction interval is narrow or confidence interval is narrower?
It should be confidence interval, sir.
Confidence interval is narrower. That is why whenever you wanted to know what is going to happen, right? We look at the confidence interval. But in order to get the confidence interval, you must have repeat experiments, right? You must do repeat experiment, and you can only expect the average to be in your confidence interval. For example, last 5 years, if I ask you what is your salary, you might say current salary is, let's say 1.5 lakhs monthly salary. And last year it could have been how much?
1.2 or 1.
Okay, but salary generally, it will increase. And let us say, our business, and this month the business is, business profit this month is 1.5 lakhs. Last month is 1 lakh. This month is 1.5 lakh. Last month is 1 lakh. So what could be the profit next month?
2 lakhs.
Will it be 2 lakhs? Will it your profit continuously increase?
Yeah.
Not necessarily.
But there is a kind of prediction, correct? Prediction or confidence.
Yeah. When you are earning, let's say, alternatively every month 1 lakh and then 1.5 lakh, 1.25 lakh, it is, always, varying between 1 lakh and 1.5 lakh. Then what could be your prediction on your next month earning? The average of it.
Yes.
The average of it, right? So when you have multiple readings, The average can, get you a value, within your confidence interval. So when you want to get a value within the confidence interval, then you must do multiple experiment and then calculate average, and average will fall inside the confidence interval. So that is why the confidence intervals are given. And when you want to know how these values are arrived, then you must use this value. What is this value? Standard error. What is this value? Standard error. So this standard error, no, see here, confidence interval is nothing but the fitted value plus or minus approximately 2 times standard error. Approximately 2 times standard error when you put, you will get confidence interval, right? See here, 30. 2 times 30 is 60. You add the 60 and you will get 160. Right? Similarly, 1 or 2 minus 2 times 40 minus 1 or 2 here. 1 or 2 minus 60, you will come close to 40. So approximately, how to reach. But if you want to be very perfect, you must put 1.96 here, and then you should also calculate the standard error of the fit correctly. So these are all, the terms associated with regression analysis. Now I will take you through the slides to understand further with respect to the correlation and regression. Any questions so far?
No, sir.